So finishing up those second two examples here. The first one, we've got 1 over 1 minus x quantity squared, and we're asked to find a Taylor series for this. Now, I want to point out a couple things really quickly. The first one is that if I look at 1 over, 1 over 1 minus x, and if I were to scroll up a little bit, we've got it right here. We could write that as the series from n equals 0 to infinity, x to the n, and that's just 1 plus x squared plus x cubed, and so on. Now, I also want to point out one more thing. If we take the derivative of 1 over 1 minus x, we're going to end up with 1 over 1 minus x quantity squared. Which looks very familiar here. So in other words, if I do term-by-term differentiation for this series here for the 1 over 1 minus x, that's going to give me the series that I want. So if we do term-by-term differentiation for up here, the 1 becomes a 0, so the x is going to become a 1. Then we have plus 2x plus 3x squared. The next one would be plus 4x cubed, and so on. So we can write this in sigma notation. This one's going to start with a 1. And we can write it as n times x to the n minus 1. So there we have it. Now our last one here, we've got x times inverse tangent of x squared. So once again, from the previous section, we were able to define the inverse tangent function as such. The inverse tangent of x can be defined as the series from n equals 0 to infinity of negative 1 to the n power x to the 2n plus 1 over 2n plus 1. Now, we're not just looking at the inverse tangent of x, though. We're looking at the inverse tangent of x squared. So replacing the x with x squared is going to give me this series. We have n is 0 to infinity, negative 1 to the n. We're going to have x squared to the 2n plus 1 power over 2n plus 1. So x squared to the 2n plus 1, you're going to end up having x to the 4n plus 2 power. Oops, sorry, my tablet's not cooperating. Here we go. So we have negative 1 to the n. Again, that's going to be x to the 4n plus 2 power over 2n plus 1. So now let's look at the whole function here. We have x times inverse tangent of x squared. So I'm going to multiply this series here by x. And it's going to be very similar to what I did with the first example in this grouping. This x can move inside here, and so instead of it being x to the 4n plus 2, it's x to the 4n plus 2 times x, which will be x to the 4n plus 3 power. So as a series, goes from n equals 0 to infinity, negative 1 to the n, x to the 4n plus 3, all over 2n plus 1.